How do IPv6 Anycast and Multicast addresses work? Imagine sending a message to a group of friends or to the nearest friend in a crowd. That's kind of how IPv6 addresses help computers communicate across the internet. IPv6 uses special address types to make data delivery smarter and faster. Two of these are Multicast and Anycast addresses. They each serve a different purpose and help keep the internet running smoothly. Multicast addresses are like sending a letter to a club or a group of friends. When you send a packet to a multicast address, it goes to all devices that have joined that group. This is perfect for sharing videos, updates, or information with many devices at once. Multicast addresses always start with the prefix FF00/8, which means the first 8 bits are all ones. This helps routers recognize that the packet is meant for a group, not a single device. Instead of broadcasting to everyone, Multicast sends data only to those who want it, saving bandwidth. For example, if you're streaming a live event, Multicast makes sure everyone watching gets the same stream without overloading the network. Multicast addresses also include a scope, which tells the network how far the message can travel. It can be limited to the local link, like your home network, or go across the whole internet. There are special multicast addresses called solicited node multicast addresses. These are used by protocols like neighbor discovery to check if an address is already in use or reachable on your local network. They are created from parts of a device's unicast address, making local communication more efficient. Now let's look at the other type, Anycast addresses. Think of Anycast as sending a letter to the nearest post office that has the same address. When a device sends data to an Anycast address, the network figures out which server or router is closest based on the routing protocol. The packet then goes to that nearest device. This helps websites and services load faster because users are directed to the closest server. For example, big companies like Google use Anycast addresses to route user requests to the nearest data center, reducing delays and improving speed. Unlike Multicast, which sends data to many devices, Anycast focuses on just one device, the nearest one. It's often used for services like content delivery networks or DNS servers. These addresses are assigned from the same space as unicast addresses, but they are configured on multiple servers or routers. When a request comes in, the network's routing algorithms decide which device is best suited to handle it, based on shortest path or lowest cost. In the bigger picture, these address types help make the internet faster and more efficient. Multicast reduces the amount of data traveling over the network when many devices need the same information. Anycast makes sure users connect to the closest server, cutting down on delays. Both methods help keep the internet scalable, reliable, and quick. So, whether you're streaming a video or accessing a website, these address types work behind the scenes to deliver your data smoothly and swiftly.